All right. So we are going to be talking over the next several days, probably a few weeks, about what we would call rational numbers. Now, I think we've talked about rational numbers before, but in case we haven't, make sure we understand what that is, rather than don't need that. What does the word rational mean?
Irrational.
It means irrational? Okay, irrational is just the opposite of rational, so rational can't mean irrational. So what does the word rational mean? Take a guess. Maybe you'll be right, maybe you'll be wrong, but, there's no fun in not guessing. What do you think of when you think of the word rational? What? Likely. Okay, so that's the way a lot of people use it, and that's okay. So people say, well, this is a rational explanation. That's what they said, right? So that means it's a likely explanation. Here's a rational explanation for the fact that it's cold out today. It's winter. That's a rational explanation, right? So that's the way we use the term, but that's actually not what the term means. That's just the way we use it. Now, I'm not saying that's not a possible meaning, but it's not. In math, rational means that it can be made into a ratio. Okay? So a ratio is something that looks like this. One number over another. What do we usually call that? One number over another. A fraction. Now, and that's the way you've always worked. That's the way all of your teachers have always described that. But it's more accurate to call it a ratio. The reality is the only time it's a fraction is if it's less than 1. Okay? That's the only time it makes sense to call it a fraction, but it doesn't. But all of your mathematical life, they've called it a fraction, and that's okay. I'm not saying that nobody was trying to deceive you. But what we mean by fraction is a small part of, right? A fraction is something that's a small part of. But every number, every rational number can be turned into this, whether it's small or big, if it's rational. Can you write it like this, with one number over a number? Now, the thing about it is that that's not true. Sorry. That's not true of every number. Not every number can be written that way. Okay? Such as, like, let's think of a number that can't be written. The square root of 2. The square root of 2, if you try to do that on your calculator, you can never write it like this. It's called an irrational number. It cannot be written like this. Okay? So that's a little bit ahead of where we're going. But, so we're talking about ratios, rational numbers. So we're going to go back to calling them fractions for a little while. And you can convert any ratio, any number that can be written like this. So such as on the screen you have 3. You have 3/8. Okay? Every ratio can be converted to a terminating decimal. Okay? Or a repeating decimal, a terminating or repeating decimal. It can be written as a ratio, it can be converted to a decimal. So Does anybody know how we would convert this to a decimal? Okay, so that's all right. That's what we're here to teach you anyway. If you look at this, you say, well, this is a ratio, this is a fraction. What would you say is the operation happening between this number and that number? What operation does this line imply? It implies division. Very good. It implies division. So here's, if you want to convert this to a decimal, okay, you just have to divide it. 3 divided by 8. Now, in order to convert it to a decimal, right, you're going to put a decimal point there and have zeros for however long it takes. So we're going to divide 8. Will it go into 3? Well, no. So that's 0. Will 8 go into 30? How many times? 3 times. 3 times 8. Okay, 8 will go into 60. What's that? 7 times? Is that right? 7 times? I know my multiplication tables, but like the rest of you, I use a calculator all the time, so I'm not as fast with them as I used to be. Okay, I'm going to 40.
I'm pretty sure.
Isn't 7 times 8, 56? Is 7 times 8, 56?
I could be.
6 times 8 is 48, right?
No, 8. I'm probably stupid.
No, I don't think you're stupid at all. But I could be wrong.
Yeah, you're right.
Are you sure?
I did it like 4 times wrong in my head.
That's okay. That's all right. No, I want you to check me because I could be wrong. It's not a problem at all. So 8 into 40, that one's easy. We know that's 5. So now, this is called a terminating decimal. 0.375. 0.375 is the decimal representation of that fraction. And you can do that with every fraction. They don't always terminate, and we're going to look at that in just a minute. But let's try another fraction. Okay, let's try another one that will terminate. So I'm going to give one to you. How about 1/4? Now, you might know that one already. But you can do it. So there's 2 ways to do it. One is to do what I did, long division. The other way is to use your calculator. So if you use your calculator, what will you type in your calculator? 1 divided by 4. Riley, did you hear that?
Yeah, 1 divided by 4.
Okay. I'm not trying to pick on you. I just want, this is the way you would typically do it, just because it's easier for you to use buttons, right?
Yeah.
So that's the way you're going to need to do it. You can, and it's okay. Okay, remember, I am pro calculator. This is why we have technology, because it makes our lives easier if we know how to use it well. So you can use a calculator to do this.
So you're pro life of calculators.
Yeah, I guess I'm just pro calculator. I don't care about the life of calculators. You can smash them with a hammer if you want. Just got to replace
You
them.
also support abortion of the calculator.
Absolutely, I'm in favor of grinding calculators up. Have you ever seen those big machines that grind up metal in cars?
Yeah.
Those are fantastic. I love those machines. So anyway, all right. So 1/4. When you take 1 divided by 4 in your calculator, what do you get? Or does anybody have this memorized? 0.25 or 0.25. So a lot of these you can memorize. When I was in school, they made us memorize all of the fourths, all of the halves, all of the eighths, and a lot of the 12ths. I don't know why, and 6ths. So I had to memorize a lot of these. I'm not requiring you to memorize them. You can work a little faster if you have them memorized. The problem with that, it's not a problem, but make sure you have it memorized perfectly, right? You don't want to mess this up and accidentally say that 1/4 is 0.35 or something. Well, that's not gonna be accurate. That's gonna mess up your answer. So now these are pretty simple. Let's try another one. I want you guys to try it. Use your calculator or do long division. I don't care. But let's try another one. Let's try. One-eighth. What is it?
0.125.
So 0.125. Okay, Lucy got that on her calculator. That's fine. You should get this. You would get the same thing if you did long division. And I think your life is helped by the ability to do long division. There will come a day, if you stick it out here with me, that you're gonna have to do long division with polynomials, and so you're gonna think, well, long division is long gone. It's not. You'll have to do long division later, and that you can't do with a calculator. You've got to do it pencil and paper, and it takes forever sometimes. But so, all right, now, yes, sir. Oh, there's your question. Let's try another one. What would we do? Well, we've got 1/8. It's a big decimal. What if we had 3 and 1/8? How will we write that?
3.125.
Okay, that is 3.125. There are two ways to do this. You can just take the whole number out. If you have a mixed number, you just pull the whole number out and you convert the fraction and then add the whole number back in. So what we did there, and this is what Connor did basically in his head, right? He said, well, I'm going to take 3 and I'm going to add that to 0.125 because I already know that that's 0.125 and you get 3.125. Another way to do that, and because this one we already had, but you might have one that you don't have, right? So you might have might have 4 3/8. Oh, well, we have 3/8 already. Let's do 4 5/8. All right, 4 5/8. And you say, oh, I don't really know what that is. Well, you can either convert the 5/8 using your calculator, or you can do this. You can turn the thing into an improper fraction. You take and multiply 4 times 8 and add that to 5. You get 45 over 8, and then you divide that. So what would you get when you do that? 45 divided by 8. What, somebody doing it?
4.6.
You might be right, but go ahead and say it.
I got 5.625.
Oh, shoot, I did it wrong. 4 times 8 is 32. 37 divided by 8. Sorry, I messed that up.
4.625.
I think you're right. 4.625?
Yeah.
Yeah. Connor, you want to tell us how you did that? I'm glad that you did it this way, by the way. I mean, I'm glad you did it, but how'd you do it? Did you know 5/8, or did you just,
I knew 1/8, or I knew what 1/8 is. And
so you multiplied it?
yeah.
Okay, that's good. That's good. That's using your head. That's doing math here. That's great. So 37 over 8, we can divide with the calculator, we get 4.625. Now, they don't all fall out so neatly, though. So, and we're going to do one of them. We're going to do this before we do it with our calculator. I know some of you are going to jump ahead and do the calculator, but 1/3. And you might have this memorized. And that's okay if you do. Anybody have this memorized as decimal? If you don't, that's all right. Okay. Well, let's try to do this by long division. So we're going to take 1 We're gonna divide it by 3. So 3 goes into 1, 0 times. It goes into 10, 3 times. Oh, shoot, sorry. 3 times 3 is 9. 10 minus 9 is 1. 3 goes into 10, 3 times. How long is this going to go on?
Forever.
Yes, it will go on.
It's a repeating decimal, isn't it?
It is repeating. So you write that like this. You put a bar over the numbers that repeat. Now, sometimes you have repeating decimals that have 2 digits that repeat. But in this case, it's only 1 digit that repeats, right? 0.3 repeating. Now, because it's repeating, it's still a rational number. If it was like this, here's an irrational number. Pi equals like 3.14, I can't remember, to something, it just keeps going, it never repeats. Non-repeating. That can never be written as a fraction, okay? It can't be written as a fraction. But this one can be written as 1 over 3. Okay, it's a rational number. You can write it as a ratio. It's a rational number. All right, so what about when there's more than 1 repeating digit? Like we'll try another one. So 6 over 11. Okay? 6 over 11. Now, you can do this in your calculator, and you're going to get an answer. We'll do it quickly using long division just to see it. So 6 into 11, 6 into 1, 6 into 11 goes once, right? No, I got this back. Sorry, 11 into 6. Sorry, my goodness. You guys got to stop me sooner. 11 into 6 is 0. 11 into 60 is 5. Get 55, right? 5 times 155. 11 into 50 is 4. You get 44. You're back to 60 again. 11 into 60 is 5. You get 55. 11 into 50 is 4. Now, you can see that pattern, right? That's never going to change, is it? As long as these are all zeros out here, you're going to get 50 minus 44, 60 minus 55, 50 minus 44, 60 minus 55. It's going to keep going forever. So you write that as 0.54, and the bar goes over both the 5 and 4 because they both get repeated in that order. Okay? Keeping up? Yes? Okay. Okay. Oh, I think there's one more concept that we need to hit. Okay. What was that? Just a second. Let's try one more option. Because sometimes they'll be like this. Okay. So 2 over 15. 15 divided into 2.00000. So 15 into 2 is 0. 15 into 20 is 1. 15 into 50 is 3. 3 times 15 is 45. You got 50 again. And that's what you're going to get. And so in this case, it's going to be 0.13, but only the 3 repeats. Sometimes you'll have leading numbers that do not repeat. But if there's going to be a repeating decimal, it will always conclude with the repeats, whatever those are. Okay? So, all right. And again, for the most part, you'll do this with your calculator. I want you to be able to do long division, I do, but long division was taught in 4th grade. We're well beyond teaching long division, okay? So I'd like you to be able to do it, but you will do this primarily with your calculator. Now, let's note, if you did this on your calculator, this is what it would look like. So you got your calculator, right, in your little box up here. Your answer is going to look like this. And it's not going to have a repeat anywhere. You have to find that, right? You're going to have to figure out that that's repeating. If it does that, that's repeating. Now here's the other problem though. What if it's 2/3? 2/3 looks like this on your calculator. Don't be tempted to look at that and think it's not repeating. Why does it have a 7 at the end? Why?
Because they want to end it.
They want to terminate it, so they round it. They round it to as far as they can write, as far as the calculator can include. And so they say it's 0.6666667, but it's not. That's why you have to be careful and make sure you understand how to do long division in case your calculator is not clear enough for you. Okay? So you should be able to do this, and I can help you with it, but we can't spend days teaching long division. All right? Now, let's suppose we want to compare some numbers, okay? So let's say we have 3/5 and 0.75, which, if we want to compare them, greater than or less than, greater than or equal to. How do we know? Yes.
You divide 3 times, or 5.
So you divide 3 by 5. So what you're doing basically is converting to a decimal. You might later be able to convert the decimal to a fraction. You can do that too. But the wise thing, honestly, the simplest thing is to convert the fraction to a decimal, or the ratio to a decimal. So when you do 3/5, what do you get?
The allocated 15.
Let's write it out. What do we get when we do 3/5?
Oh. 0.60.
0.6. Okay, 0.75. All right, so you have 60 or 0.6, 0.75. Which one is greater? Right, this is less than. 0.6 is less than 0.75. Right? So you have to convert them to decimals to compare them. Now, again, you might have the ability with some of them to do something in your head, right? So if instead we had 1/2 compared to 0.98, well, probably you know the decimal for 1/2. What's that decimal? 0.5 or 0.50, either way it works. So you would look at that and you would say, I know that one. I know that that's 0.50, and I know that that's less than 0.98. So you probably can do that. So you might know some of them, but you basically have to convert them either in your head or in your calculator to do it. All right. So I know I'm going to skip through a couple slides because we just talked about them. All right. We want to try some of these. Let's just make sure. we'll do the first couple together, meaning I'll do them on the board. You still gotta do them on your work, by the way. Yes, sir. Sure. So here's number 14. Number 14 is 3 over 20. Okay? Now, you might do this with your calculator. I'm not sure what the instructions tell you. It doesn't tell you whether you should with your calculator or not. So I'm open to you using your calculator. I'm going to do it by long division. So 20 into 3 is 0. 20 into 30 is 1. 20 into 100 is 5. Once you get to a 0, you have no remainder, you are done. So that decimal, number 14, is 0.15. But again, you might have done that with your calculator much faster, and that's okay. All right, so I'm gonna let you guys work on these, and then if you need help, I'm here to help you. This gives you time to work on them in class. You should be able to complete them in class and not go home with homework tonight. In case it snows and you get to enjoy the snow tonight or snow day. Yes?
So for number 16, it shows that there's a negative. How do I do that?
Excellent question. I'm sorry, I should have mentioned that before. So when you have a fraction, okay, so number 16 will, what is that? That's negative 5/8. Okay. It's written like that. Sure. But any fraction that is negative can be written in one of 3 ways. It can be written with the negative out here in front of the fraction. It can be written as negative 5/8, or it can be written as 5/8. A negative fraction implies that either the top or the bottom, the numerator or the denominator, is negative. It does not imply that they are both negative, because if they were both negative, then the answer would be positive. So when you have a negative fraction, all you really need to do is change your decimal to a negative decimal. But if you want to type it in and see it, you can just, what I do, I always make the numerator negative. So every time I see a negative fraction or a negative ratio, I envision it like this, because it's always the same value, right? It doesn't matter if the denominator is negative or if the numerator is negative. The total fraction is negative, so I always I always make my first number negative. You don't have to do that, but I do. So, and again, if you're doing it long division, you're just going to make it negative anyway, right? Because a negative divided by a positive or a positive divided by a negative is negative. If the signs are different in division, the answer will be negative. All right? Everybody good? Cool. Yes.
How much do you use it?
On your computer?
I mean, I can make it my computer.
Let's say it is. Let's
Yeah,
just say it is.
It is totally on the computer.
Yeah, it's just a good.
Hey, may I look at Facebook? It's totally
No,
on my
that you can't
computer.
You're not allowed to look at
Yeah.
Social media.
social media here. Yeah, your social media is blocked.
It would have totally been on my computer.
Yeah. Well, technically, a phone isn't how you computer. So you couldn't say it's on the computer.
It's on the miniature computer.
I know this feeling out.
Oh,
You can move this.
what kind
Move
of
stuff
thing I
around if
have
you need to
to
make it
toggle?
fit. They're kind of irritating.
Oh, wait, what?
Make it next bit on there.
We have Miss Wagner.
I'm stealing your energy.
Oh, not as kinetic
There's a
energy.
ton of things during manners you didn't tell you.
No, it's for a long time.
I know what we have after this.
Did you clear what we have after this?
After Peter.
Oh, where's Frank?
After food computer.
Really? Don't we need town?
What?
That was the day we had, thing.
No, that's Monday, Thursday. That's Tuesday, Friday. No, there's a bonus.
What?
I don't find that. Oh, okay.
You lost the math book.
I'll put this on Google Classroom. Just so you can- Oh, shoot, I need stuff to do.
Oh, you can have that. Yeah, he said he's gonna put it in the classroom.
Okay.
Yeah.